Assalamu alaikum. Ramadan Kareem. Okay, our last two little lessons here, guys. We're going to just talk about Pythagoras. It's the most famous theorem in all of mathematics, okay? It's used so much. Why is it used so much? Well, remember we were just studying polygons. Well, and when we were looking at the interior angles of a polygon, we could break every polygon into triangles. And then you can take every triangle and break it into a right triangle. So there's this special relationship that humans have known about for thousands of years now. And there's a man named Pythagoras, a Greek mathematician. He's not the one that came up with this. It was in Babylonia, Iraq, years and years and years and years and years ago. And of course the Egyptians used it. Everybody who messes with triangles, of course. Okay, so this is one of the main. There's a whole bunch of proofs of the Pythagorean theorem of why it's true, right? Here's a visual one. Okay, draw a big square, and then you cut a right triangle in each corner. Same right triangle over and over, right? It doesn't matter how big you make this. You could do it on graph paper if you want, or and check. It's easy to do it on graph paper, right? Don't have to. I made it a 7 by 7 big square, right? 7 by 7. And then I cut little triangles that are one leg is 3 high and the other leg is 4. So there's 4 triangles, all the same. In the center, these make a square, and the area of this square, we're just labeling the sides A, B, and C. 2 legs are A and B. And the hypotenuse is the side across from the right angle, right? A hypotenuse is the side that does not touch the right angle. Okay, so the hypotenuse is C. And so the area of a square, remember, is base times height, C squared. Okay, so the uncolored, I colored in each one of the triangles. And I left the center square open. So C squared is not colored. Okay, and I got the same big square, 7 by 7, and I move these triangles around where I have a rectangle over here that is A by B, right? Base of B, and this one has a base of A and a height of B, the same rectangles, right? I move these 4 triangles around. So now I have A times A here, A squared, and B squared, right? B times B, this square is B squared. B times B is B squared, A times A is A squared, C times C is C squared. Well, if I had the same big square, right, the 2 big squares are the same size. Here, what I have missing is the hypotenuse squared. The hypotenuse of the ABC triangle, C squared, that is unshaded. Over here I have leg squared plus the leg squared, A squared plus B squared. So I love this little proof. I think it's the easiest one to see. A squared plus B squared, if I had to put them backwards, equals C squared. Okay, A squared plus B squared is the same area as C squared. Okay, there's my favorite proof of it. I made this one other little design. I want to put it on the wall, but I haven't made it nice and artistic yet. I start with there's a 90-degree angle at a 1 by 1 inch, doesn't matter, both these need to be the same length, all right? And if you call them 1 unit, this is 1 unit from here to here, 1 unit from here to here, and it's half of a square. Well, this diagonal is 1 squared plus 1 squared. Oh, I can't quite see the work. Sorry, guys. Let's see. I'll bend the camera up there a little bit. I did the work. 1 squared plus 1 squared equals C squared. Like finding this diagonal here. C squared equals, 1 plus 1 is 2. You take the square root of both sides, you get C equals the square root of 2. So you can generate, and then you make a right angle here, and do that same length. So the outside edge is always a length of 1, and if you go ahead and do your Pythagorean theorem over and over, you wind up making this cool spiral. And I just had to stop because I was running off my paper, but you can spiral it on around. So you're going to have square root of 2, square root of 3, square root of 4, which is 2. So then you can remeasure this and see if you're being accurate or not. This length from here to here is 2. Well, it better be twice as much as each of these out, and it is. Okay, on mine. Square root of 5, square root of 6, square root of 7, square root of 8, square root of 9 is 3. So this length here is 3 times as long as this one. You keep going, you'd get the square root of 16 up there somewhere. 4. Anyways, neat spiral that it makes. And this is another little cool thing of the Pythagorean theorem. Okay, let's do, that's enough of that. And then I'll do the problems and work the problems in the next video.